Hi, my name's Terry Sloan. I work at EPCC, which is the University of Edinburgh's High Performance Computing Centre. Over the years, I've worked on a number of projects concerned with processing large amounts of data. And so, what I'm now going to do is give you a very brief talk that discusses what big data is and how you can go about handling it. So here's an overview of my presentation. So first of all, I'm going to talk a little bit about what some of the definitions of big data are and how you can go about characterizing it. Then I want to talk to you about how you can actually go about using big data, and specifically I'll talk about data science. And overall, what I would like you to be able to get from this brief talk is to understand some of the implications of dealing with very large data sets, what you could do about these implications, who are the sorts of people you should work with when you're working on projects with big data, and also give you some of the technology that's often, the terminology rather, that's often used when talking about big data. So, big data. I'm afraid it's quite a buzzword. I'm sure you've heard it many times mentioned in the media in recent years. And the thing is, it really actually means different things to different people. And so it can be hard to tie down a specific definition. And also, an important aspect of it is that what one person considers is big, for another person can appear to be quite normal. And so to help illustrate that, I've got a quote here from one of the O'Reilly books, online digital books, titled "What is Data Science?" And here the author makes this interesting statement about big data, where he says, "Big is really a red herring. Oil companies, telecommunication companies, and other data-centric industries have had huge data sets for a long time. And as storage capacity continues to expand, today's big is certainly tomorrow's medium and next week's small." And I think that's an important point to bear in mind when you think about what big data means. It does mean different things to different people, and it very much depends upon what you're used to handling in terms of data volumes. So one of the useful ways that you can characterize big data is using what's known as the 3 V's, which refer to volume, velocity, and variety. And these refer to the volume of data, the velocity of the data, and the variety of the data that you're dealing with. And again, this is a quote from another one of these O'Reilly online books. This one called Big Data Now. And so, given that you've got these V's to help characterize big data, then here's another quote from the Gartner IT consultancy, whereby they now refer to big data as high volume, high velocity, high variety information assets that demand cost-effective, innovative forms of information processing for enhanced insight and decision making. So, what do we mean by these V's? What do we mean by volume, velocity, and variety? So let's look at each of these terms in relation to big data in a little bit more detail. So let's go first of all to volume. So what we're talking about here is when the amount of data is too big for your conventional IT infrastructure to process. For example, it might be your PC or your departmental computer cluster. Then, in effect, what you've got is big data. And you need to come up with a way to help you deal with that. Now, Depending on the actual volume, it might be as simple as yeah, if you're using your PC, it might be as simple as going to if your department that you work in has got a bigger departmental computer that you can use, where you've got access to more resources, more compute resources, more data storage resources, then it might be as simple as doing that. But for some, it might be that they're already using a fairly significant computer resource, and they have to think they need even more than that. And so in these sorts of circumstances, this is where people start thinking about using scalable storage and distributed queries. So effectively what we're talking about is you get access to facilities whereby you can add more and more disks, more storage space as you require it. And what you do is, to enable you to process your data, you end up using what's called distributed queries. You effectively split your data processing up into tasks that can process different parts of your data set at the same time. So if you've got a spreadsheet that's too big, if you find that you've got a spreadsheet for your laptop, on your laptop that is just too big, then really then the sort of flow through to what you would do next then is you might then look to, okay, let's see if my departmental computer cluster has got some sort of database management system which can deal with the spreadsheet and the volume of data you've got in that spreadsheet. But it could be the case that is not enough, and then that's where you start getting into the technologies which help you deal with scalable storage and distributed queries. So this is whereby we're talking about massively parallel database management systems, and one such technology out there that is called of that nature is Greenplum, or else you might be talking about using data warehouse technology, and one such example is Teradata, or using something called a distributed file system, and the Hadoop distributed file system is another example there. And these technologies allow you to add on storage as you need it, and allow you to split up your data processing into the various tasks to process your different parts of your data at the same time, and therefore help you overcome the issues that you're having with your existing IT infrastructure. So that's volume. So let's talk about velocity. So velocity, what we mean here is we're talking about the rate at which a data flows into an organization or into a project or whatever, and the speed at which you can make decisions based upon that data. You know, how quick is the feedback loop? How quickly, as your data comes in, how quickly can you react to it and make a decision upon it? And this sort of fast-moving data is often referred to as streaming, or less commonly, you might see it referred to as complex event processing. So yeah, why might you do it? Well, it might be that you've lots of sensors gathering data, and you wish to be able to react to what those sensors are saying to you. But the thing is, if you've got lots of data, you've got too much data coming in that's going to be, and you don't have enough storage capabilities to store it, then what you need to do is be able to process that as it comes in, and it might mean actually throwing some of the data away. And a particular example is the Large Hadron Collider, which I'm sure you've heard of, where the Higgs boson was identified relatively recently, and that's one particular instance whereby they've got lots of data being processed live, and they don't have enough storage, so therefore they will throw away some of that data. So that's handling of the streaming data is something that's important for them. Okay, and some of the streaming technologies are things like Apache Storm. Okay. So next, variety. So this is another aspect of big data. So another characteristic. So this is where you've got data that is, data is nowadays, you're getting data from many different sources that you want to process. You might have images, you might have videos, you might have the sensor data, you might have tweets, you might have all sorts of things. Now these all have different formats, and I have different levels of structure. Some can be quite structured, some can be semi-structured, some can be unstructured, completely unstructured, and somehow you want to bring all that together to to do some sort of analysis. And the thing is, conventional database management systems are not always ideal. They can't always handle this changing and diverse nature of such data infrastructure. So this is where things like NoSQL, what's often referred to as NoSQL database management system approaches can help you with this. This is using things like the MongoDB document-based data management system, or things like using Cassandra, a columnar-based approach to handling data, or things like Neo4j, which is a graph-based approach. These are all other ways whereby you can try to deal with that diversity of data that you're dealing with, and hopefully be able to process it. Okay, so we've talked about 3 V's, but there's actually a whole range of other V's that have recently come about as well in when people are talking about big data. And of these, there's only really one other one that is useful to be aware about, of, and that is value. And for many, this is the reason why big data is popular. So, because you've got these large amounts of data available to you now, for many people, it means they can now consider doing things that they could have not done before. Certain areas of research, certain types of business, are now possible, which were not possible before. Because of the sheer volumes of data that you've now got available to you, the speed at which you can process it, and the way that you can handle the different types of data. So for many people, that's where big data really has become important. It gives you value. So you've got large data sets. Now, how do you actually go about using that? Well, this is where another term that you've probably come across, data science, comes into play. Data science is really about the tools and techniques and technologies, etc., that you can use to actually processing data to get some information out of it. So let's look at that and some of the terminology in there and some of the definitions. So this is a definition from this Gartner IT consultancy, whereby they say the data science, the person who's actually going to do the processing of the data, is critical for organizations looking to extract insight from information assets for big data initiatives, and requires a broad combination of skills that may be fulfilled better as a team. So it's saying that you rarely do you find this broad combination of skills required to deal with big data type projects in one person. Often you need to have it's a range of people that are involved. And to sort of illustrate that a little bit further, here's the definition for data science that's on the University of Edinburgh's Doctoral Training Centre for Data Science. And it says this: data science is the study of the computational principles, methods and systems for extracting knowledge from data. Although this is a new term, there's a sense in which this is not a new field, because it is the intersection of many existing areas, including machine learning, databases, statistics, numerical optimization, algorithms, various other things as well. So given that, what has come about many in recent years is this notion of the data science skills diagram. It's a Venn diagram, obviously, that shows the different skill sets that people typically believe are important for doing data science, and their intersection, and where the different terms that you hear discussed within the field relate to each other. So computing skills, that's obviously a very important thing. Data analysis knowledge, statistics, clearly an important thing as well to have. And then finally, domain expertise. So what the domain in which you're working, then obviously you need to have that knowledge. So in traditional research, so you see that over there at the intersection between data analysis knowledge and domain expertise. Yeah, typically in research over the years, not only have you had to know about your particular topic that you're investigating, but you've also had to bring some stats knowledge, some other knowledge into play to help you analyze the information that you're researching in your particular domain. At the intersection between computing skills and this data analysis knowledge is the notion of machine learning. It's a very topical term again these days, but here we're talking about using algorithms and techniques to be able to glean information from data, and it's very much seen as sitting between at this intersection of computing skills and stats, data analysis knowledge. And then in the center, you'll see that there's this, at the intersection of all three is where data science is generally held to sit. It requires all three major skills of the major skills here. It requires the computing skills, it requires the data analysis knowledge, and it requires the domain expertise. And there's a more informal take on this, which I'll show you, which is from Drew Conway, right? I'll talk about this area here, danger zone, in a wee minute. Okay, this is the one that everybody goes, oh, danger zone, what's that? Well, I will come to that. Okay, so this is, before I talk about danger zone, I want to let you see a more informal way of thinking about this Venn diagram. And this is, in some ways, is the origin of this Venn diagram. This is Drew Conway's original take on it, whereby hacking skills has now replaced the term computer science, and substantive expertise has replaced the term domain expertise. But we've still got the same intersection terms. It's quite an interesting article to read, this particular link if you want to know more about the origins of this. So the danger zone. Let's talk about the danger zone. So this is effectively people who know enough to be dangerous. So you've got some level of computing skills, whereby you're able to extract and structure the data and process it, and you know quite a bit about the actual field, the domain that you're working in, and you can even run a linear regression. But it might well be that you lack the understanding of what the regression coefficients actually mean. And so the danger here is that you have the ability to, as it says here, create what appears to be legitimate analysis without actually understanding how you got there or what you've created. Yeah, it's very easy these days to go and pick up a stats package and use that to process a particular data set, but without actually properly understanding what it is you're doing and what the results of the particular techniques or functions you've applied to your data actually mean, and whether you've actually applied them sensibly as well. And this is where the danger zone sits. And a really well-known example in the medical field, at least within the data science and big data community, is the Google Flu Trends project, where it was the idea was that with Google, then by analysing search terms, the expectation was that you'd be able to predict trends in flu cases. Well, over the years, this was, after a very short time, this was dismissed as actually just not really being very good at all. And so there's links here to a couple of articles about that are definitely worth having a look at to make you more aware that when you're setting out in some of these big data projects, you can't just abandon the views of the statisticians and the mathematicians about how you actually go about dealing with data and dealing with your experiment design and things like that. It's really important to consider these things when you're actually embarking on such big data analysis projects. And this blog article I've mentioned here talks also about the Google Flu and just Trends project, and also there's some other useful links in there generally about being telling you to be cautious when you are dealing with big data sets and dealing with tools that are very easy to access and apply, but you need to be thinking very carefully about what it is that you're actually doing, what these things are actually saying to you. Okay, so I'm going to wrap up now, and I just in final, this is my final sort of point I want to make. So big data requires you to think differently about how you work with the data, because you're going to have to think about how, if your volume is very big, how you might split up tasks. If you're wanting to deal with data that comes in quickly, and have to think about doing some sort of streaming processing. You've got a lot of data from lots of different sources, then you have to think about how you deal with the diversity in the formats, things like that. But the thing is, if you can deal with that and make sure you don't get caught out by being in that danger zone, then it can provide good new insights and offer more value to you. Thank you very much for listening. I hope you found that useful.